Hi students, Miss Marta here. Today we're going to learn about the greatest common factor and the least common multiple word problems. All right, let's begin. Let's take out that notebook of yours and let's turn to the next new page. And I must stress to turn to the very next page in your notes, in your notebook. Otherwise, it becomes difficult to find your notes when you need them, okay? So on the very top line, let's write the date, whatever date it is for you. And skip a line or two, and then let's write the title, GCF and LCM word problems, okay? And then, as you can see, I have written my notes ahead of time. Since today we're dealing with word problems, there's a lot to write, and I'm trying to keep the lesson as short as possible. So I have pre-written all of my notes ahead of time. So go ahead and pause the video at any given moment so that you can write down whatever is on the screen and then unpause and return to the lesson. All right, so let's begin. GCF word problems may ask to split or divide things into equal or identical sections, to arrange sections into rows or groups, and to arrange sections into their largest grouping. Okay, let's talk about these guidelines or these little clues. When they're asking you to split or to divide things up, what they're looking for there, and especially when they want them to be into equal or identical sections, right? Equal or identical. That lets us know that they want you to find factors. Because remember, when you are dividing something, then the answer to a division is a factor of that number. So we're looking, that lets us know we are find factors. That's a clue to let us know we're finding a factor or a divisor. GCF is also known as GCD, greatest common divisor, just so you know. Okay. Another clue we have here is largest. That's another clue. If they're asking you for the largest, you know it's not a least common multiple problem, it's greatest common factor. So that lets us know that it's the greatest. They may use also the word most, as in my example, okay? Right here where they talk about rows or groups, that is, that's in reference to these equal or identical sections, but it's just, I find it's very popular to have word problems asking for things to be arranged into rows or groups. Okay, let's look at our first word problem. All right, skip a couple of lines and start writing the word problem. Yes, I know you have to write it out. So write it out and, pause the video, write it out, and then come back. Okay. Gigi is arranging identical bouquets of roses. She has 36 pink, 48 red, and 54 yellow roses. What is the most number of bouquets she can make using all of the roses? How many of each rose is in each bouquet? Okay, so let's begin. Clearly, the biggest clue I see here is when they ask you, what is the most number? That clearly lets me know that it's a GCF problem. In fact, that's what this question is. They want to know what the GCF is, okay? The follow-up question that they have here, how many of each rose is in each bouquet? It's not a GCF problem, but you'll see how it's related to the problem, to GCF when we work it out. Here's another clue where they say, hey, they want identical bouquets. And that's our unit, number of bouquets. Okay, so you know what the numbers are. They're 36, 48, and 54. So go ahead and solve it on your own. Try to find the GCF and then come back to the video. All right, I'm going to tell you probably best to write tiny because I'm looking at my page. I've got very little left. I know I kind of broke my rule of not putting too much on a page, but looking at my page right here, that's my entire page. I'm about halfway through and I have just enough space to work it out, but I'm going to keep my work small so it all fits. Okay. So let's talk. We have 36. which is 6 times 6, and each of those is 2 times 3. We have 48, which is 2 times 24, and 24 is 8 times 3, and 8 is 2 times 4, and 4 is 2 times 2. We have 54, which is 6 times 9, and 6 is 2 times 3, and 9 is 3 times 3. All right, so let's write them out. We have 36, which is 2 times 2 times 3 times 3. We're writing out our prime factorization. Remember, just put all your factors in order. 48. Let's see how many we have. We got 1, 2, 3, 4 twos, and 1 3. So 1, 2, 3, 4 twos, and 1 3. 54 equals, I can see it's 1 2 and 3 threes. Is it 1 2 and 3 threes? All right, so I'm going to now highlight what is common. We have a set of twos in all of them, and no more twos because 54 doesn't have any more factors of 2. So we're going to take a factor of 3 from each group. Okay. So the GCF is 2 times 3. So our GCF is 2 times 3, or 6. We have six bouquets. Oops. 6 bouquets. Bouquets. All right, so we're looking for 6 bouquets. I'm trying to get my spelling right. All right, we have 6 bouquets. Now, the next question they're asking us is how many of each rose is in each bouquet? I'm going to switch my colors here. Let's go to green. All righty, here we go, my green. If I look at my prime factorization, the answer is in my prime factorization. Whatever is left over, that is the answer to the question. So you see that in the pink roses, we have 36 pink roses. Right here, we have 2 times 3. Okay. And for the red roses, we have 2 times 2 times 2, which is 8. And for the yellow roses, we have just a 3. Is it just a 3? Oh, I'm missing a 3. Sorry, I missed out a 3 on when I was writing my answer. Let me go back. There was another 3 here. Missed it. All right. So there we go. We got 2 3s. All right. So that lets us know that we have 6 pink roses, 8 red roses, and 9 yellow roses in each bouquet. All right, so that answers that second question. Let me clean this up a bit. In each bouquet. All right, I'm going to zoom out so that you can see the entire page in the work. Okay. Now we're almost done. Now we're going to talk about LCM word problems. And here we go. LCM word problems may ask about an event or an occurrence. Let's go back. Let's get another color here in my highlighters. Let's go with the orange. I kind of like the orange. They may ask about an event or an occurrence that will repeat again and again. And they may ask to figure out when something will happen again. This has to do with multiples. Okay. And when it will happen again is referring to the least of those multiples because it's the soonest. It's the earliest. The earliest. So is the earliest references, let me rewrite this a little neater here. Earliest is refers to being the least. Okay. And you'll also see a lot of units of time. That's very common because it may be, for example, or the number of the events, units of time. So you might have things like days, hours, minutes, weeks. Those are often clues. Yeah. Okay. So let's do our example right here. Again, pause the video, write it all down, and it's short, and we're almost done. Ben runs a 5K every 12 days, and Isabel runs a 5K every 8 days. If both runners run a 5K today, in how many days will they both run a 5K together again? So, noticing the guidelines I wrote above the problem up here, okay? Notice they want to know in how many days will they both run a 5K together again? When is the next time? That is a clue that it's a least common multiple problem because they want to know the earliest when that will happen. Another clue again is they're asking about every 12 days. Every 12 days and every 8 days. So not only do we have our units of time there, we can see that it's a cycle, it's repeating, and that lets us know that it's multiples. All right, so let's begin. Let's do this problem. So we're going to basically find the LCM of 8 and 12. Okay. We got plenty of space now, so we can write 8 is 2 times 4, and 4 is 2 times 2, and 12, that is 3 times 4, and 4 is 2 times 2. So if I put my LCM together, 8 is 2 times 2 times 2, 12 is 2 times 2 times 3, and if I'm going to notice 4 is a common factor of both numbers, and we're only using the 4 once. So in the GCF, sorry, not GCF, LCM, for our LCM, we are using that 2 times 2. Okay, that is this that I circled. Okay, and we have that 2 times 3 that's left over from in each of them. That's the 2 and the 3 that's left over. These two are these. And this, we use it only once. Remember, again, I can look at this as being 8 right here, and 12 is this. And there in the center, you see that 4 is the common factor. All right. So what is 2 times 2 times 2 times 3? Well, that means that the LCM is 24. So we have 24 days. That is how many days it will take for them to run the 5K together again. Another version of this word problem would be if they gave you the day of the week, instead of saying that they ran a 5K today, they would say, if both runners run a 5K on a Wednesday, in how many days will they both run, or what day of the week, sorry, if both runners run a 5K on a Wednesday, in what day of the week will they run a 5K together again? You'll still do the problem the same way. You're just counting off from the Wednesday. So then you'll start counting, Thursday, 1, Friday, 2, Saturday, 3, and you'll just count out until you get to the day of the week that they're asking. So that's another version of this very same question where they're being specific on the days of the week. You may even find it on a standardized test where the choices are the days of the week. They give you 4 days of weeks. They'll give you a Monday, a Tuesday, a Wednesday, a Saturday, and you have to figure out which day of the week is the correct answer. So that is it. Let me zoom out for this full page so you can see the entire page. Okay. And so that is it for today. So what I want you to do now is definitely go and either do a handout, do IXL, do practice. It's the only way you're going to get good, because what you want to do is find those clues to let you know and just differentiate between one type of problem and the other. I also will follow up on in my videos in my video series on guided practice with a handout which deals entirely with uh, least common multiple and greatest common factor word problems. And they're not telling you what they are. You're going to have to figure out which one it is. So if you want, come back. And also, please like and subscribe to the video and my channel. And I'll see you for the next lesson. Okay.